Thank you for watching my video. My name is Mr. Charles Wenike. In this video tutorial, we are now on construction of a capacitor. This is a new topic. We have treated dielectric materials. We treated dielectric laws. We treated dielectric constant, dielectric strength, and so on and so forth. We also discussed some of the materials that are involved, the disadvantage and advantage, and so on and so forth. So in this case, we have to start from construction of a capacitor. And this tutorial, you will understand how capacitors are constructed. But I will use one or two polarized aspects of capacitor to explain what I mean, how capacitor is constructed. So in that case, before I proceed with that, please, I would like to say, if you like my video, subscribe to my channel, comment, like, and share. Thank you for doing that. So in this case, as I said before, there are different types of capacitors. There are different types of capacitors. These different types will have different type of construction. There are different types of capacitor. These different types of capacitor have different types of construction. Let me use human being as an example. We are all human. As we are human, we have different faces. We have different names as well. And since we have different faces and different names, we also have different attitudes. Irrespective of the person that creates us is one God. But we have different reasoning, different picture, different destiny, and different behavior altogether. That is the same thing applicable to capacitor. They have a general name called capacitor, but there are different types of capacitor, different types and different constructions as well. Now let's take a look of the aspect of it, the construction. Now let us understand the construction of this capacitor. It consists of two metal plates separated by a distance. Capacitor, the construction aspect of it consists of two metal plates separated by a distance. Now, how is it separated? It's separated by a distance. That distance, what makes it to be a distance is that the dielectric. And in that distance, it has two legs. It has two legs. Some capacitor has three legs, depending. But in this case, the distance that we are going to discuss is why does it consist of two metals separated by a distance? Now let's take a look of that. Now this is the construction of a capacitor. I use this just for the sake of explanation. Now this capacitor is an image or the fourth prayer, as in is it the skeletal or it's not a schematic diagram. It is called a diagram of a capacitor. Let me use that word. Permit me to use that word, a skeletal. Now, in this case, here from our left hand side, we have the one that has positive at the right hand side, negative at the left hand side. And in that case, the distance that you are seeing, those arrows that is going from positive to negative, is called the electric field. The one that is moving, the arrow that is moving from positive to negative, is called the electric field. Now, in between that electric field, it is called dielectric, because it has a dielectric that will enable the positive shift to negative, and also the negative will shift to positive. So in that case, the two pole, these two things that you are seeing here, is called charge conductive plate. It is called charge conductive plate. So in that case, the positive is called holes, while the negative is called electrons. The positive is called holes, while the negative is called electrons. And these things that you're seeing here from left and right, they are all called wire. And that wire could be a positive wire and a negative wire. So this is just the skeleton, the picture of it, how how a capacitor is constructed, the basic construction of a capacitor. Now let's come to the middle aspect of it, where it has charges, positive charge and negative charge. The same thing you can also see from here to this plate. It is called the plate. This plate that I first mentioned, which I call charge conductive plate, it is called the distance. The distance between the positive and negative, the difference, it is called the distance. So in that case, from this point to this point, it is called the distance. Now, in this middle aspect, the middle picture of this is obvious or apparently that in between the positive and negative, you can see that between those sides, it has positive, it also has negative. The other side, it has positive, it also has negative in one area, because positive will shift to negative, and negative will also shift to positive, and that is how it works. So in that case, in the side of positive lead here, being this wire, it has negative and positive in it. In the side of negative, it also has negative and positive in it. And that is how construction of capacitor has been made. All these things work in the process when it has been subjected to electric field. So on that process, there must be a shifting, and that shifting is called it is called a polarization. It is called a polarization, which cannot be seen physically. You cannot see it physically. It can be viewed by a microscope. So in that case, what I'm trying to explain here is the plate area of A, which is you can see here is Q. This Q here is called a charge, and it is called a negative lead. Here is a positive lead. Now, for you to understand this much better, this is now all these charges, all those things that makes it to move is called when they are subjected to electric field. So in that case, I repeat, the distance between this positive and negative is the plate separation. It is called the distance. Now, these two is when it is under current, when it is under electric field. Now here mainly it is when it is under electric field influence. In this place here there is no electric field influence. So because if there is, you will have seen the reaction, the movement of it. Now this symbol is telling you that once it is under electric influence, there must be a shift. Now let's go to the one that is at the right hand side. All these ones are called uncharged capacitor. This one is when it is not on electric influence. So in that case, the distance here, all these things are the same thing called the dielectric. Here also is dielectric as well. So in that case, just as I said before, the distance here and here, the two poles are conductive plates, which is a distance. Now here you can see that is non-electric field. Here is electric field. Here is when it has been charged to move from one, it has been charged to a certain stage or state that the polarization take place. Here there is no electric field influence. Here this is the starting point, while here this is where it has gotten to a point where the polarization take place. In this place here there is no electric field influence on that. So that is what you should understand. Now the space between the two plates is filled with dielectric material, which I have already explained it before. The two legs of the capacitor are taken from these two plates. The two legs of the capacitor are taken from these two plates, which is here. The two legs of the capacitor are taken from the two plates, the positive and the negative. This one is positive, this one is negative. Here is positive, here is negative. Here is positive, here is negative as well. And in this area, it is called electrical neutral. That is when there is no electric influence. So in that case, the capacitance of the capacitor depends on the distance between the plates and area of the plate as well. The capacitance of the capacitor depends on the distance between the plate and area of the plate as well. The area of the plate is just let me use this thing to explain it more. Now you can see that this is a plate area. This is plate area A, electric field E. So the area, this is the distance. The area is a surface. It's just how you are, how the movement when it has been under influence, the polarization aspect of it. Once it has been under influence, which means that area of both sides, there must be a shifting of it. So that is what I mean by that. So in that case, the capacitance of the capacitor depends on the distance between the plates and area of the plate. The area of the plate where the distance has been positioned from positive and negative. So in that case, the capacitance value can be changed by varying any of these parameters. The capacitance can be changed by varying any of these parameters. What are the parameters? A variable capacitor can be constructed by making one of these plates fixed and others to move. These are the the parameters that I am talking about. A variable capacitor can be constructed making one fixed and the other one variable, being either increasing or decreasing, moving it. That is what I mean by variable. Thank you once again for watching my video. Please, if you like my video, subscribe to my channel, comment and like. See you next week, the same day and time.